Ready to get done.
Example 21.
We have
The
7
proton
minutes.
is placed 0.02 meters from an unknown charge. The proton feels a force of 0.0003 newtons towards the charge. What is the magnitude of the electric field at this location? I got a mess. Sorry. All right, so we know Q. Now, the proton, is this a big Q or a little Q?
Can you turn the thing on?
Yeah. Let me write down the radius real quick. The force. Okay. Is the proton a big Q or a little Q?
Little Q.
You sure?
Positive. No.
Okay. Is the proton creating the field or experiencing the field? It's experiencing the field, so that's our little Q. Right? So little q is 1.6 times 10 to the negative 19 coulombs. Right? So we have a Q, an F, and an R. Okay? We want to find the force exerted, the electric field, right? See, man, that's why I had to think of it. Sorry, I'm not mad at you, man.
I'm sorry.
Okay. What is the magnitude of the electric field at this location? Perfect. So, which equation should we use?
F over, I don't know.
We have these two equations. E equals KQ over R squared, and we have E equals F over Q. Now, if you are simply just matching equations to what I've given to you, you're going to use this equation.
Use the second one.
Or you're going to try to use this equation because you have a Q and an R. Right? Right?
Yeah.
But if I use this equation, I'm figuring out the electric field created by the
Little Q.
proton, by the little q. We want to figure out the electric field created by the unknown charge, so we need to use this equation. Alright? So that's why I gave you too much information. Alright? So, E equals F over Q. E equals 0.0003 divided by 1.6 times 10 to the negative 19th. Right? So 0.0003 divided by 1.6 times 10 to the negative 19th.
1.875 times 10 to the 50.
Yay.
Block, why are you cussing?
Oh,
The tables have
1.875 times 10 to the 15th
You used to give up those.
newtons per
second coulomb.
coulomb.
Culo.
Okay.
What does that spell?
Money. Now, since the E field is positive and the force are positive, we know that those two are in the same direction.
Right. Smell that?
Smells like someone's cooking something.
Like cinnamon rolls.
Okay. All right. So that was example 21, right? Right? Example 22 says we have a small charge. Example 22 says a negative 6 microcoulomb charge is placed in a negative 400,000 newton per coulomb electric field. What is the force felt by each charge? Okay. So this one's a little more straightforward for you. That 6 microcoulombs is big Q or little Q?
Little Q.
Little q is the one feeling the field, not creating the field. It's the one feeling the field. Okay? The charge experiencing the field. Right? So little q is negative 6 microcoulombs. E is negative 400. Newtons per coulomb. Right? So the two charges are separated by 0.05 meters. Right? We want to find the force on both charges. And we want to find the Q creating the field. Right? So we have some big Q, and little q is some distance away from big Q. Right? And we want to figure out the force exerted on both charges. So some big Q and little q is some distance away. Now the electric field is negative, right? Guys, the electric field is negative, so that means it points which way?
Outward.
The electric field is negative, so that means the electric field points what?
Outward.
Inward.
Inward. The electric field points towards the big Q. Okay? So electric field points towards the big Q. What does it tell us about big Q? Is it positive or negative?
Negative.
It's going to be negative. Okay. Now we want to figure out the force on both. Now how can I figure out the force on both?
First
Equation.
equation.
We have the two equations. E equals F over Q,
Equation 2.
or E equals KQ over R squared. Which one will tell me the force?
The first one.
The first one. But isn't this, if I use this equation, E equals F over Q, we can figure out the force on little q, right?
Yeah.
Okay.
Just put it in.
So let's figure this out. So E is negative 400,000. F we don't know. Q is negative 6 microcoulombs, so 6 times 10 to the negative 6 coulombs. Right? To get the negative 6 out the bottom, we multiply. So 400,000 times negative 6 times 10 to the negative 6. So negative 400,000
4.
times negative 6 times 10 to the negative 6. What'd you get?
6.6 times 10 to the 10th.
2.4.
Scott, I think yours is too big. Okay.
Yeah, but
400,000 times 6e, or not 6.
square.
Yeah, 6e negative 6.
2.4.
Yeah. 2.4. What?
How do you come up with that?
With these problems?
What is going on? You just throw out random numbers in here and there? Or?
No, I usually figure out what I want the answer to be, then work backwards. Right. So 2.4 newtons. Does that make sense, guys?
Yeah.
Scott, you figured out?
Yeah, but I thought I did it right with last time. Yes, I did.
Well, it's time I think you divided. Okay.
I might have.
I think you either put the E word for the F or you did the algebra wrong. Alright. So the force is 2.4 newtons on little q, right? What's the force on big Q?
Negative.
What?
This is the force on the little q, isn't it? What's the force on big Q?
Same thing?
Same thing. Why the same thing, Nan? Good. Newton's third law. Alright. Big Q, Rex, pay attention please. Big Q and little q push on each other the same amount. Even though one is bigger than the other in terms of charge, they still push on each other the same amount. Coulomb's law says that whatever force you apply, and Newton's third law, sorry, says whatever force the big Q applies to little q applies that same force to big Q. Alright, does that make sense, guys?
Yes.
Newton's third law strikes again, huh? Alright, so we gotta do one more thing now. So that is this right here is the force on both. Just the directions are opposite, and they'll both be away from each other. The reason why we know it's away from each other,
Positive.
okay, good, it's positive.
Very next.
Any questions?
No.
Alright, now the second part we gotta figure out what big Q is. There's a couple ways. I can take this force and use Coulomb's law, KQQ over R squared, and figure it out.
Yes.
Or I can take this electric field and E equals KQ over R and figure it out that way.
So the first one.
I want to do the second one.
Okay, the
So-
answer's negative 1.
We're going to use E equals KQ over R squared to figure out big Q. So we plug in everything we know into E equals KQ over R squared, and we solve.
Where did negative 9 come from?
Word what?
Negative 9. 9 times 10 to the
Oh,
negative 9.
positive 9. Thank you, Ned. Okay. So I'm going to simplify the right side. 9e9 divided by 0.05 squared. We have negative 400,000 equals 3.6 times 10 to the 12th. So we divide by 3.6 times 10 to the 12th.
0.185
What?
Did you multiply by 0.05?
Did you get that?
Yeah, I did 9e9. Well, I did 9e9 divided by 0.05 squared. I simplified the right side. Scott, I did not give you a. So Q equals negative 1.111 times 10 to the negative 7 coulombs.
Oh, it's because
Didn't do the right electrostatics.
Okay.
I used
Let's watch the senior video, everybody.
Alright, so now our prediction that this was negative was correct.
Yes.
Does that make sense?
Yeah.
Any questions?
Yes.
So one last thing, okay? When we look at this, guys, this is really negative 0.111 microcoulombs. It is smaller than little q, but that's okay. Okay? Big Q isn't necessarily bigger than little q all the time. Okay? It's not always necessarily bigger charge. Big Q just means the charge creating the field that we're looking at.
Okay.
Alright? Any questions?
No.
I thought that was your
Crazy type of thing.